Okay, continuing with 3.5, part 2. So still talking about parallel, and now in this case, perpendicular lines. So definitely know that perpendicular lines intersect at a right angle. And then also, like in a diagram, if you have the little square in the corner between two lines, or it could be segments as well, that means perpendicular. So the slopes of perpendicular lines, if you know the slope of one line, then the slope of a line perpendicular to it is the opposite reciprocal. If you're taking a look in the textbook, it'll say the slopes of the perpendicular lines multiply together to equal -1. That's still the same as the slopes being the opposite reciprocals of each other. So the slopes of two perpendicular lines are opposite reciprocals of each other. And we will review what opposite reciprocals are just in case you've forgotten. So for example, let's just say the slope of one line is 5/6. Then the opposite reciprocal of that, you want to do two things. Okay, you want to take the opposite. So if it's positive, make it negative. If it's negative, make it positive. And then the reciprocal is switching or flipping the numerator and denominator. So the opposite reciprocal of 5/6 is -6/5. The opposite reciprocal of 4 is -1/4, because 4 is the same as 4/1. The opposite reciprocal of that is -1/4, and so on. The opposite reciprocal of like -1/9 is +9. So those are opposite reciprocals of each other. So then for example 2, kind of like example 1, it says write an equation of a line passing through this given point, but is, sorry, I forgot to change that. It should say is perpendicular to. Y is equal to 2/3 x minus 1. So similar to the previous example, example 1, I'm going to write my equation, and it should look like this. Y is equal to mx plus b. So the two things that we need to fill into this equation are m, the slope, and then b, the y-intercept. So if the line that I'm trying to write the equation to passes through this point and it's perpendicular to this line, what we want to use from this line is the slope. The slope is 2/3. Okay, so the opposite reciprocal of 2/3 is -3/2. Or I can write it like this if I'm going to use symbols and abbreviate it. The perpendicular slope to 2/3 is the opposite reciprocal, so -3/2. And then I can plug that into this equation. Y is equal to -3/2 x plus b. So we need to find the y-intercept. Just like on the previous example, we have a point. Again, just like the previous example, but you have to be careful, even though I forgot to change it at first. I want to write an equation now that's perpendicular. So we're taking the opposite reciprocal slope. If it were parallel, we would take the same slope. But I'm going to label this point xy because we could use those coordinates in order to find the y-intercept b. So y is -2. That's equal to m, -3/2, times x, -2, or I'm going to make it -2/1. The reason why I'm doing that is because we have to multiply by a fraction. Before we multiply, here's what I'm going to do. Cross cancel. So 2 goes into 2 once, 2 goes into this 2 once as well. And then you have to see what's left. Like I have a negative here and negative here. Negative times a negative is a positive. And then 3 times 1 is 3/1, and then plus b. So then we could solve this for b by subtracting 3 from each side. -2 minus 3 is -5. That's equal to b, or b equals -5. So the y-intercept, or b, is -5. The slope is -3/2. Those are the two things that you need in order to be able to write your equation. So then the final equation looks like this. Y equals -3/2 x plus -5 or -5. That's an equation of a line that goes through the point -2, -2. So if you graph this line, it would pass through the point -2, -2, and it's perpendicular to the line y equals 2/3 x minus 1. If I graph both of these lines, here and here, they would be perpendicular in a coordinate plane. And the easiest thing to or easiest place to see that is if you actually graphed it using a piece of graph paper.